Aloha everybody, this is Gigi from Kauai Community College. This is a video on implicit differentiation, problem number 2, example number 2 here. So be sure you are already viewing the example number 1 before this one, okay? So suppose the question is asking you for the equation of the tangent line at to this curve, and this curve is x squared plus x multiplied to y minus y to the third power is equal to 7 at the point 3, 2. So what we know is that the equation of the tangent line, we will need to know the slope, right? In order to find the equation. And the slope would be dy dx, change in y over change in x, or the instantaneous rate of change. So we are looking for that, okay? So in order to look for that, previously, before we learn about implicit differentiation, we would have to get y by itself. So you would have to be able to solve for y, to say y equal blah, 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 and then you can say dy dx is equals, and then you will apply whatever rule that is to find dy dx, right? Now look at where y is. Y is right here, and y is right here. So it is very hard for us to find dy dx. So forget about the idea of solving for y to be able to take the derivative explicitly. We have to do this using implicit differentiation. And what that means is we will treat y as a function in terms of x, so that the chain rule will apply when it comes to taking the derivative that involves y in there. Okay, so what do I mean by that? So here is the magic, right? We would go and take the derivative of both sides. So we would say take the derivative with respect to x, take the derivative of this with respect to x, and then take the derivative of that with respect to x, and then take the derivative of this with respect to x. Now that looks kind of messy. I wrote that just to make the point that we are going to take the derivative of the left-hand side and the derivative of the right-hand side. However, you don't have to write that on your paper. So here is magic that is happening. And we want to also, and I also want to focus on the why I wrote that. I wrote dx, meaning we are taking the derivative with respect to x. So x is our variable here. X is our independent variable, and y is a dependent variable, meaning y is a function in terms of x. So whenever we take the derivative that involves y, we need to consider the inside derivative, which is dy dx in there. Okay. So the derivative of 2x is, the derivative of x squared is 2x, right? Because we are taking the derivative with respect to x. The derivative of x multiplied by y, that is a product, so we have to apply the product rule here. And the product rule said the derivative of the first, which is 1, multiplied to the second, which is y, plus the derivative of the second, which is the derivative of y, and the derivative of y is dy dx. Not just 1, but 1 multiplied by the inside derivative, which is dy dx, multiplied by the first function, which is x. Okay, and that is what we call implicit differentiation. And then the derivative, so minus the derivative of y to the third is 3y multiplied by the inside derivative, which is dy dx. And that will equal to the derivative of 7 with respect to x is 0. Okay, so that right there is very important step there. Make sure you know that y is a function in terms of x, so that we have to multiply by the inside derivative, which is dy dx. Now, what are we looking for? We're looking for dy dx, which is the ones that I just shaded there. So let's clean this up and solve for dy dx. So here we have 2x plus y plus x dy dx minus 3y, oopsie, there should be a square right here. Okay, the derivative of y to the third is 3y squared, and then multiply by the inside derivative, which is dy dx. So minus 3 y squared dy dx equal to 0, and that's how you clean that up. And again, we are looking for dy dx, so we're going to keep these terms here on the left hand side. Anything else without dy dx will be going to the other side, so negative 2x minus y. And then here we can factor out dy dx, and this would be x minus 3y squared. So dy dx will equal to negative 2x minus y all over x minus 3y squared. And that is the derivative as we want it. Okay, and then what we now are going to do is to find the equation of the tangent line at that point. And since the point is 3, 2, we would say that when x and y, when x is equal to 3, y equal to 2, then the slope of the tangent line will equal to, so it will be dy dx evaluated at 3, 2 is negative 2 multiplied by 3 minus 2 all over 3 minus 3 times y squared, which is 2 squared. So that would be negative 6 minus 2, that would be negative 8 on the numerator. On the denominator, you have 2 squared, which is 4. 4 times 3 is 12. 3 minus 12 is negative 9. So really the slope is 8/9. That's the slope of M. And the point is 3, 2. So now we can go ahead and find the equation of that tangent line. So we would say the equation is y equals mx plus b. M is 8 over 9. X is 3. Y is 2 plus b. 3 divided by 3, 9. 9 divided by 3 is 3. So you have 8/3. So for b, minus 8/3 over 2 is the same as 6/3. Minus 8/3 is negative 2/3. So then the equation of the tangent line at the point 3, 2 is y equals 8 over 9 times x minus 2/3. And that is our final answer. Okay, but how did we get there? We got there by taking the derivative, and we took the derivative implicitly. And why do we need to take the derivative implicitly? Because the equation that we were looking at is in the implicit form, meaning we couldn't solve for y to be by itself.